Okay, so next lab for Chem 20 in the solution unit is taking that nice copper sulfate solution we made and diluting it. So you can reference this in the textbook, page 228. Okay, so here's your nice solutions you made the other day. Looking pretty good. What we're going to do is we're going to dilute this. So we're not going to add more water to our solution to dilute it. What we're going to do is we're going to take a specified volume from here and transfer it to a new volumetric flask and make another solution up to the 100 ml line. Okay, so you're going to use this equation, C1V1, concentration by volume, equals the new concentration by volume of the new solution. So this is your original solution, and this is your diluted solution. Okay, so let's just watch how it's going to happen. So we just want 10 mils of this solution, and you never pipette out of a volumetric flask because the neck is so narrow that it's easy for this pipette to get broken. So instead of pipetting directly from the volumetric flask, we're going to pour it into a beaker. So I'm just going to transfer this into a beaker. You might, you don't necessarily need to pour it all out because you only need 10 mils, depending if you want to keep this solution for another lab or keep it on the shelf to use in the future. So I'm going to take 10 mils from my original stock solution and I'll transfer it to a clean volumetric flask. So as you know, when you pipette, this is the bulb and this is the pipette. So you're going to squeeze the pipette, put it on top, and as you let the pipette go, water or your solution will get drawn up the pipette, right? So it's going to get drawn up. It's working on pressure. That little line there, that's the top of the pipette, and that's where you need to draw the water. That would be exactly 10 mils. Now there's lots of different kinds of pipettes, but some of them hold solution in the tip and some of them don't. So never push the water or your solution out of the pipette. Just pull it up and then just let it go into your volumetric flask. Okay, so I'm going to pull up 10 mils of the solution. If you're uncomfortable with pipetting, you should definitely practice first. Okay, so you want to be careful not to pull the solution up into the bulb, so not too high, and then you just use your thumb and release it until it gets to your mark. So my thumb, I'm going to stop my thumb now and come to eye level, and yeah, that looks pretty good. I'm at 10 mils, and then I will just transfer to a volumetric flask. And I'm just going to let it go. I'm going to let it go naturally. I never want to see you pushing out the solution into the flask. Okay, there you go. And you will see that there is a little bit left in the tip. That's fine. That's the way they're designed. So don't feel like you need to get every single drop out. They're designed that way. Okay, I'm not going to put this tip on my bench because I don't want to contaminate my bench. I'm going to put it right over top of the sink, and I'll have to clean that when I'm done. All right, so there's my concentrated solution. And now I've got 10 mils of my concentrated solution, and I'm going to add volume with a distilled water bottle to bring this up to the 100 ml line. All right, so you can there's no rinsing the volumetric pipette. You're just going to add water up to the 100 ml line. When you get into the neck of the volumetric flask, it starts to fill really quickly, and at that point you need to be a little bit careful. If you wanted to use a funnel and pour from a beaker, you could do that as well. You can already see that the color is much lighter, so you can see it's a more diluted solution. So I'm just adding solvent, and I'm going to slow down once I get into the neck. Okay, so there I'm in the neck, so I'm going to go a little bit slower, and I'm getting close to the meniscus. And when I get to the very end, because this is precision chemistry, I'm going to use a clean beaker of water and a little mini pipette, or if you've got eyedropper, you could use an eyedropper. And I'm just going to bring it up to the line. Okay, so it's probably difficult to see that line. So now I've got 10 mils of my original solution. I've topped it up to 100. My last step is to stopper it, invert 3 times to evenly distribute the solute. 1, 2, ich-ni, san. There we go. And that, ladies and gentlemen, is a brand new diluted solution. It's 1/10 of the original concentration of the original solution. And if you look at these colors, you can see it's certainly diluted. And let me just show you this calculation on the board. So this is your equation. See, concentration by volume equals concentration by volume, right? So this is your original, and this is your diluted. So we took 10 milliliters of a 0.05 moles per liter copper sulfate pentahydrate solution. And our new situation over here, I don't know my new concentration, but what's my new volume? Well, I brought it up to 100 milliliters, right? So now I can solve for C2. I can solve the new concentration. Now, if you look at this, you can see that the units aren't matching. So I'm going to have to change this milliliters to liters.
Miss J. Ford, please dial 2114.
So now I have liters. That liter and that liter will cancel out, and I'll be left with moles. Over here, I can change this to liters. And I'm going to be solving for concentration. So this moles divided by this liters will give me my new concentration. So C2 will equal 0.005 moles per liter divided by just moles. We've lost that liters already. It's already been canceled. Divided by 0.01 liters, moles per liter.
You have to multiply the top by 0.01. 0.05 times 0.01.
Right, you have to do that first. Our liters is gone, so that's going to be 0.005,
Yeah.
right? Or is it?
Yep.
Okay? So anyway, that's for you to do, not for us to do. That's your job. All right, so that's it.